Welcome to Flemdog Tutorials. Today we're going to be looking at ions and formulas. If you have any questions you want to know, just let me know. We'll work those out in the future. Let's look at this right here. So we have this ion, and we'll look at how to make that into an ionic compound. And then we'll do one that will break apart, where we take the compound and say, what was the ionic structure of the species involved there? So first up, we have aluminum as an ion, 3+, and chloride right there. So how do we make this into a compound? Well, first, just a little bit of recap so we know what we have. Aluminum, if we think about its valence, I'll just draw 3 electrons on here. The aluminum has 3 electrons that are valence. Its outermost electrons there that will get taken. And when it loses these electrons, draw those getting lost. So when that goes, and this goes, and this goes, when those all get taken, it was balanced with protons and electrons. So the protons equaled the number of electrons. But when it loses 3 electrons that are all negative, it becomes more positive than it is negative. So since it lost 3 negative things, it is now 3 positive. So aluminum, 3 positive, and chloride, what happens to it is it has 7 valence electrons right there, and it would really like to get an 8th right here. It'd like to get that 8th valence electron, and currently it is balanced with protons and electrons, but if it gets one more electron, which it has here, then it has one more negative thing than it does positive. One more electron than our positive protons. So what we've said is we've had an electron come in right there. So that's just a little bit of background. How do we draw this then? What we have, I'll redraw it so we got space here. We have our aluminum, 3+, and Cl-. How many 1 minuses do we need to cancel 3+? Ionic compounds always come out to something positive plus something negative coming out to 0. Currently, 3+ plus 1 minus would come out to 2+. We need to get it to 0. So how are we going to do that? Aluminum, 3+. This gets us to 2+. Another one gets us 3 plus 2 minus is 1+. 3 plus 1, 2, 3 minus gets us to 0. So this means aluminum, there's 1 of, and the chloride, we drop the ending when you're naming these. Drop the ending, add the "ide." The aluminum becomes aluminum chloride, and there are 1, 2, 3 of them right there. This would be our final aluminum chloride ionic compound. A fun little simple way, you kind of got to double check this, but that you can use. So notice we have 1 aluminum and 3 chlorides. Here's a fun little technique. You take the charge and cross them. So I have 1 thing here, 1 aluminum, 1 aluminum. I have 3 positive, that 3 goes right there to the chloride, and I have 3 right there next to the chloride. So you just bring those charges down to the opposite one. Sometimes you got to reduce that, but it's a fun little technique. Now let me show you the other one when we're splitting them apart. If we have potassium nitrate, I'll go a little faster on this one. So we have potassium nitrate. Now, with these, we want to know that potassium is in our group 1 right here. All of these will become +1 every single time they become an ion. So that means potassium becomes +1. NO3, this is one you need to memorize. I'll put parentheses around it. This is called nitrate. NO3. That's a polyatomic ion, and it always has a 1- charge. So as ions, it is potassium ion and nitrate ion. So that's what this would look like in its ionic formula there. Hope that helps. And I will see you again soon. Let me know if you have any questions and we can get those figured out.
Wonder, oh wonder.